Hello, in this video I'm going to look at the specific problem. If you're given sine of an angle, theta, so there's theta, is square root 3 over 5, and theta is in quadrant 2, find all the 6 trig ratios, and of course one of the ratios is right here, square root 3 over 5. So let's take a look at what this is telling me. What I know is, if this is a circle, and I have an angle theta in quadrant 2, what that means is I actually rotated from 0 degrees, right? I rotated from 0 degrees and I rotated past 90 and somewhere between 90 and 180. So I just did this. Starting at 0, I rotated like this, right? And I ended somewhere in here in quadrant 2. Now what that means is this is my terminal side, right? From the origin to the edge of the circle. This is the actual angle, but how we represent it is we drop a perpendicular to the x-axis, right? So now you have a vertical line and a horizontal line, and so this is your right angle. And across from your right angle is the radius or the hypotenuse. And this angle in here, that's your reference angle. The reference angle theta is between the terminal side and the x-axis, okay? So now what they're saying is sine of theta is square root 3 over 5. Now I purposely chose square root 3 because students don't like roots. Square root 3 is just a number, and I believe, let's take a look, it's 1.8, or 7, I'm sorry. Let's just find it. Yeah, it's 1.732050808. It's just a number. So you could put in here approximation and go 1.7 over 5, if it makes you comfortable, like just to see it temporarily. Square root 3, though, is symbolically more important because it represents an infinite number, or an irrational number that goes on forever and ever, which we can't really define any other way except symbolically, because we never know the next digit until we measure it. So anyway, this is just that. You have the length of, so let's go back and go ahead and use the definition of sine. The definition of sine in terms of x, y, and r, what is that? Pause if you need to. You should say y over r. So essentially what we know is this. Y, the ratio of y over r is square root 3 over 5. And so what we know is essentially y is square root 3 and r is 5. So r equals 5, and here y equals square root 3. Okay? What we don't know is x. That's what we need to find. But this is a right triangle, so if you check out one of the videos, there's a proof for the Pythagorean theorem, but we know that a squared plus b squared equals c squared, right? Where c is always the hypotenuse or the radius. And in our case, we're going to say x squared plus y squared equals r squared. Now we don't know x, so we'll just leave it there as x squared. The y is square root 3, so we're going to have square root 3 squared, and is equal to r 5 squared, okay? Now, let's drop this to the next page. I'm just going to rewrite it. X squared plus the square root of 3 squared equals 5 squared. All right. Now, what this means is now I can start simplifying a little bit. So square root 3 times square root 3 is just 3. No more square root, right? And then 5 times 5 is 25. So now we just need to solve for x. I subtract 3 from both sides. So x squared equals what? 22. Okay. And let me clean this up just a tad bit. It's bleeding through from the other stuff. All right, so now that we know x squared is 22, we need to take the square root. So we're going to take the square root of both sides. And what you should write, technically, is the square root of x squared is the absolute value of x. And that's going to be equal to the square root of 22. Then to remove the absolute value, you're going to just write x, and then here you're going to write plus or minus square root of 22. So I'll go into this in just a bit. Let me finish the problem, and then I'll come back and explain that a little bit. So now we have the triangle, and we know that x is either positive or negative square root of 22, but because we're in what? Quadrant 2, we know x has to be negative, so x is negative square root 22. Okay? So now we know that x is negative square root 22, y is square root 3, and r is 5. Right? Now that we know x, y, and r, we just use the definitions, right? We say, okay, I know that sine of the angle is y over r, so that's square root 3 over 5, which they gave us. We know that cosine of theta is x over r, which is negative square root 22 over 5. And we know tangent of theta is y over x, so that's square root 3 over negative square root 22. And you can put the negative sign in front if you want. And you could write it, remember this right here could be written as negative square root 3 over square root 22, or negative square root 3 over square root 22, or square root 3 over negative square root 22, right? They're all the same. The only thing is, in the book, they don't accept a radical in the denominator, so what you're going to have to do is you're going to have to multiply by 1, but the 1 that you choose has got to be something that will get rid of this root, so you're going to multiply by square root 22 over square root 22. But I want you to realize that what you're multiplying by, this right here, is actually just 1. So you're changing the form, not the value of this original number here. So now what you're going to have is square root 3 times square root 22, and let me put this as an aside. Basically, this is what you have under the root, 3 times 22, but that's really what? 3 times 2 times 11. Well, since you don't have two factors that are the same, like 3 times 3, you can't pull anything out of the radical, right? So you just have to leave it that way. So you're going to have square root of 66. So this is square root 66 over 22, and it's negative. Right? All right. And then you're going to get all the other ones, you're just going to take the reciprocal. So the reciprocal of sine is, pause, it's what? And you should say cosecant of theta. And then you're going to take the reciprocal of these, so you're going to have 5 over square root 3, but remember, you got to rationalize, so you're going to have square root 3 over square root 3. So you're going to have 5 square root 3 over 3. And then here, the reciprocal of cosecant is secant. So that's going to be 5 over square root 22, and it's negative. You're going to multiply by square root 22 over square root 22. So secant theta is equal to negative 5 square root 22 all over 22. And then finally, over here, cotangent, you're going to have to do the reciprocal, so you'll have square root 22 over 3, and it's negative. Square root 22 over square root 3, and you're going to multiply by square root 3 over square root 3. So cotangent theta will end up being negative square root 66 over square root, I'm sorry, not over square root, but over 3. That's the whole reason we did it, is to not have a square root. Over 3. Okay? So there's your 6 trig functions. Hopefully that, if you need to pause it, go ahead and pause it. Let me just get back to this over here. This is really from algebra. Let's see, where was it? It was over here. When you take the square root of x squared, y is at the absolute value of x. So let's take a look at that. If you recall, let's say you had something like x squared equals 4. Well, the truth is, if you're trying to find x, right, well, what would solve this problem? What is it? What number can I plug in there and it gives me a true statement? That's what you're trying to say. Well, technically, you don't know if it was a positive 2, right, because positive 2 times positive 2 is 4. Or you don't know if it might have been negative, because a negative 2 times a negative 2 is also 4. Both would work. So that's why when you take the square root of something squared, you must put it in absolute value. And then, to remove the absolute value, you say, oh, okay, that means it was either positive or negative. Okay? All right. Thank you so much for listening.